Have you ever wondered why carbon is the backbone of organic chemistry? Why do we have over 16 millions of known organic compounds with even more yet to be discovered? Hi everyone, welcome to Chemistry Portal. Today we are starting from the very basics, what makes carbon so special and why it forms such a vast number of compounds, and this is the foundation of organic chemistry. So let's start. So first point is why why carbon why carbon is so special is so special. There are currently over 16 millions of organic compounds known to us and many more. But why are there so many carbon containing compounds? Why not other atom other than carbon compounds? Right? And the answer lies in the periodic table. Okay? So first of all, let's write it here. 16 million plus 16 million plus known organic compound and many more possible. Okay, but the question is why there are so many compounds of only carbon, right? And the answer lies in the periodic table. So let's write here the carbon position, the position of carbon, the position of carbon in the periodic table. Okay, so before this you can write here why there are so many compounds of carbon containing compound. Okay, so write it here, why are there so many carbon containing compounds. Okay, and the answer is what? The answer lies in the periodic table. So let's see the periodic table. Okay, let's copy this and here paste it. Okay, so if you see here we have a periodic table. Okay, and here we have carbon, right? And if you go in the left side of the carbon, most of the elements behave as metals, right? And if you go in the right side of the carbon, most of the elements here are non-metals, right or not? Okay, if you see the carbon is in the middle, right or not? Here 3 elements and this side we have 3 elements, and the carbon is in the middle position. Okay, so write it here, the carbon present in the second row, carbon present in the center of the second row in the periodic table, and if you see here the left side of the carbon all elements are behave as more metallic nature. More metallic nature means more metals, and here in the right side most of the elements are, all the elements are non-metal, right? Okay, so we will write it here, and we know that metals like to lose electron, right? So I will write it here, metals lose electron and non-metals accept electron, right? Accept electron. So if you see, if you go in the right side of the carbon, all are the non-metals, and non-metals will try to accept the electron. And if you go in the left side of the carbon, we will see here all are metals, okay? All are having a metallic nature, and all the metals wants to lose the electron, donate the electron, okay? But what about carbon? Carbon what will do? Okay, so let's write here, left side element of the carbon, they will try to lose electron, and right side element of the carbon, they want to accept electron, okay? So if you go in the right side of the carbon, they will try to accept electron, and if you go in the left side of the carbon, they will try to lose electron. Clear? Right. Okay. But the question is, what about the carbon? Carbon will lose or gain. So see here. What about the carbon? What about the carbon? The carbon will lose or gain. The carbon will lose electron or gain electron? No, neither. Carbon neither lose electron nor gain the electron. Carbon will not lose electron and carbon will not gain the electron. The carbon will share the electron, right? Carbon will share the electron. Carbon will share the electron. This carbon will share the electron. Okay? So, carbon is different. Okay? Carbon is different. It will neither accept, it will neither lose. It prefers to share electron, and that is the unique property. That is the unique property of the carbon, that the carbon is capable of forming a vast variety of compound. Understood? This, due to this property, due to this nature of carbon, carbon share the electron, and due to this property, the carbon makes so many compounds, so many variety of compound. Understood? So write it here. Due to this unique property, of carbon, it forms variety of compounds. This is very, very important. Okay? The carbon do not lose electron. carbon do not want to gain electron, rather than carbon want to share the electron. And this is the unique property by which carbon forms a variety of compounds in the organic chemistry. Okay, so we can write the what can carbon do? Okay, understood. What can carbon do? So we can write here carbon can share electron. First point, carbon can share electron with many elements. Second point, carbon can form a strong covalent bond, and we will talk about in more detail about this covalent bond. Okay, all these things will come in the upcoming lecture. Okay, so don't worry about this. Okay, third point is bond. Carbon can make bond with itself, that is a CC bond, or C double bond C bond, or C triple bond C bond. Okay, single bond, double bond, triple bond. We will talk. Okay, now don't worry. We will talk in so much detail about this. Okay, what is called single bond, what is called double bond, what is called triple bond. We will talk more in detail. Okay, in the upcoming lecture, slowly. Okay, don't worry. Okay, I am here. Okay. Okay, so the fourth point is carbon can create long chain and ring. Okay, carbon can create, or carbon can form long chains and rings. Okay, and these two property of the carbon, third point and the fourth point. Okay, like carbon can bond with itself, like CC bond. Carbon can make bond with itself, carbon bond, like that. C single bond C, C double bond C, C triple bond C. This property and this one, carbon can form long chain and ring. These two property combined, it is called catenation. Now you will ask me, sir, what is called catenation? So catenation is, so I will write it here. Catenation is, it is a self-linking of atom of an element to create chain and rings. Okay, and due to this property, catenation, carbon forms a variety of organic compound. Okay, right? So, and now organic chemistry is not about just carbon compound. Okay, it's about how they will react. Understood? Organic chemistry is not just about carbon and all. Understood? It's about how they will react, how the reaction happens. Every organic reaction involves some bond breaking and some new bond forming. Okay? Every organic reaction involves some bond breaking and some new bonds will form. But how easily a bond form or break depends on the electron involved in the reaction. Right? And that brings us to a fundamental question. What are called electrons? Where are they located? How it looks like? Right? So write it here. We will write it now. So organic chemistry is what? Organic chemistry is nothing but a study of carbon compounds and their reaction. Organic chemistry is nothing but a study of carbon compounds and their reactions okay, and the reaction involved, and this reaction involves bond breaking, bond formation. Okay, so we'll write it here. Reactions involved bond breaking and new bond forming. Okay, during the reaction, these two things happen: bond breaking and new bond forming. We will talk in more detail. Okay, don't worry. Okay, this is just a basic fundamental. Okay, and to understand the reaction, we must first understand the structure of atom, the role of electron, right? Okay, so this is about reactions. Now if you want to understand organic reaction, we must start at the atomic level. We need to explore the structure of atom, how electrons are arranged, and how these electrons determine the bonding and reactivity in the reaction. Okay, so we'll write it here. To understand the reactions, we must first understand the structure of atom, of an atom. Second point, the role of electron. Third point, how electron participate in bonding, and that's how we will understand organic reactions in a very simple manner. We must have to start at the atomic level, like what is called electron, proton, neutron, how the electron is arranged in the molecule, in the atom, where are they present, orbital, subcell, all things will come. Okay, we are going very step by step. Understood? And that's exactly what we will be covering in our next lecture. Understood? And that was just the beginning. In the next class, and we will go more deep in the atomic structure and electron behavior. That is a very essential and most important concept for mastering the organic chemistry. If you find this helpful, hit the like button, subscribe, to chemistry portal and leave a comment with your questions. See you in the next lecture. Thank you everyone. Thank you again.